Hi, this is Hani. I am on the CoderPad online website, and they have a sandbox that you can use. And I implemented a binary search tree in Ruby, and I want to share it with you. So on the left-hand side, we have the code, and you can get the code from GitHub. It's on my GitHub account, and I'll provide this link at the bottom of the YouTube video. And this is the raw code. You can copy it, and then you can bring it here to the left hand side and paste it and run it. So what running it involves is you basically just save the file, and I have RSpec. It's you're going to be running an RSpec test, and all the test does is generate a random integer array, and I fixed the size to 15 element. And the idea is we want to make sure that the tree fits here on the right hand side, the terminal. So again, the left hand side is the editor. In here we have the terminal, and the RSpec results usually show up in here on the right hand side. So let's go ahead and run it. And what I did is, as we're inserting the elements into the tree, I added a delay, a sleep of a quarter second, and then every time we insert a new element, I print the screen on the terminal. So it's going to flicker a little bit, but at least you can see how the insertion is happening. Let's run it a few times, and I'll talk briefly about it. So I'm in Vim mode here, and just saving the file :W will trigger the running of the tree. Very nice. So as you can tell, I'm using backslashes, forward slashes, and dashes to draw the tree. And every now and then we get some crowding. So element 45 was supposed to be just on top of 39, and we can't have that, so it got shifted a little bit to the right, and as a result 58 also gets shifted to the right. So let's run it again. Oh, perfect. We have a perfect tree. There is no collision, no crowding, and this is perfect. I like it. So let me talk a little bit about the tree implementation. So it's basically we have two classes. So we have a node class, and the node class is just basically a container of data. And we have the tree class. So the binary tree is made out of trees of trees of trees of trees, and each tree has a node. It points to a node, and it also points to a left child and a right child. Now these two guys, the left child and right child, are both themselves trees. And both these classes, the tree class and the node class that I showed you just a few seconds ago, are aggregated inside a binary search tree class. So the idea is the driver of everything that happens is the binary search tree containing class. So this is binary search tree, and it aggregates the tree class and a node class. So that's how it was implemented. And so some of the code is implemented using recursion, and other code using iteration. So I just basically followed something that I had worked on a while ago. And back when I was in college, I took a data structures class, and it was my code was implemented in Objective-C, the first iteration of Objective-C. And it was innovative back then because it was solving a data structure problem using object-oriented programming. So I just wanted to share this with you. Again, the code is on GitHub, and it'll be at the bottom of this YouTube video. Okay, thank you.